In the next 20 minutes, you'll learn the fastest and most reliable methods to solve linear systems on the SAT, using elimination, substitution, and strategic shortcuts. Let's begin. In this masterclass, you're going to build a complete and practical understanding of systems of equations, the way they actually appear on the SAT. First, you'll learn how to use elimination efficiently. This method is often the fastest on the test, especially when coefficients line up nicely. Next, we'll explore substitution, which becomes the better choice when one variable is already isolated or easy to isolate. You'll also learn how to identify special cases, such as when a system has no solution or infinitely many solutions, something the SAT loves to test. We'll then look at how to translate real-world word problems into systems, a skill that unlocks many medium and hard-level questions. Finally, we'll cover how to choose the best method for each problem and avoid the most common mistakes that cost students valuable points. By the end, you'll feel confident tackling any system the SAT throws at you. When we talk about a system of equations, we're really talking about two or more equations that must be true at the same time. In this masterclass, we'll start by focusing on systems of two linear equations. Each equation on its own represents a straight line on the coordinate plane, and each line shows all of the possible solutions to that single equation. But when we put these two lines together, something powerful happens. The point where the two lines intersect is the one and only pair of values that satisfies both equations simultaneously. Geometrically, this intersection point gives us a visual way to understand what a system is really asking for. Find the x and y that work for both equations at the same time. Throughout this lesson, we'll use diagrams and intuition to make each idea clear, so that by the end, solving systems will feel logical, visual, and even enjoyable. Now, let's walk through how to solve a system of linear equations using substitution. This method is especially helpful when one of the equations can be easily solved for a variable. Step 1. First, take one of the equations and solve it for y. Here, we use the equation y equals 2x plus 1. This gives us a clear expression for y in terms of x. Step 2. Next, substitute this expression into the other equation. The other equation in our system is y equals minus x plus 7. Since y equals 2x plus 1, we replace y in that equation. This gives us 2x plus 1 equals minus x plus 7. Now, the equation contains only one variable. Step 3. Let's solve for x. Move the x terms to one side and the constants to the other. Adding x to both sides gives 3x plus 1 equals 7. Then subtract 1 from both sides, 3x equals 6. Finally, divide both sides by 3, giving us x equals 2. Step 4. Now substitute x equals 2 back into our earlier expression y equals 2x plus 1. Plugging in the value, we get y equals 2 times 2 plus 1, which simplifies to y equals 5. Conclusion. So, the solution to the system is x equals 2 and y equals 5. This is the point where the two lines intersect on the graph. Substitution breaks the problem into manageable steps and helps you clearly see how the solution emerges. Let's work through a more challenging example to practice the substitution method. We want to solve the system of equations shown on the screen, 3x minus y equals 4, and 2x plus y equals 11. Our first step is to solve one of the equations for y. From the equation 3x minus y equals 4, we isolate y by moving 3x to the other side. This gives us y equals 3x minus 4. Next, we substitute this expression for y into the second equation. So we take 2x plus, parentheses, 3x minus 4, parentheses, equals 11. Now we combine like terms. 2x plus 3x is 5x. So we get 5x minus 4 equals 11. Add 4 to both sides to get 5x equals 15, and then divide by 5 to find x equals 3. Now we substitute this value back into the expression for y. Using y equals 3x minus 4, we plug in x equals 3. Y equals 3 times 3, minus 4, which simplifies to y equals 5. Therefore, the solution to the system is the ordered pair 3, 5. And just like before, this point represents the intersection of the two lines. Here are the key ideas you should remember about the substitution method. First, choose one of the equations and solve it for a single variable. Often, solving for y is the simplest choice. Next, take that expression and substitute it into the other equation. This turns the system into a one-variable problem that you can solve normally. After finding the value of x, substitute it back into the expression you created in the first step. That will give you the value of y. Every solution to a system represents a single point where both lines intersect. If your algebra is correct, both equations will lead you to that same ordered pair. Keep these steps in mind, because they create the foundation for the next method. Let's move on to the elimination method, another powerful way to solve systems of equations. Unlike substitution, where we isolate one variable and plug it into the other equation, the elimination method works by combining the two equations in a smart way. The goal is to add or subtract the equations so that one of the variables cancels out. When a variable disappears, we are left with a single variable equation that is much easier to solve. Once we find that variable, we substitute the value back into either of the original equations to determine the remaining variable. This method is especially efficient when the coefficients of x or y are already aligned, or can be aligned with a simple multiplication. In the next slide, we'll look at a concrete example and walk through the full process step by step. Now, let's walk through a full example using the elimination method. We want to solve the system made of the two equations 3x plus 2y equals 12, and 5x minus 2y equals 8. Notice that the coefficients of y are positive 2 and negative 2. This means the y terms will cancel out if we add the two equations together. So we add the left sides and the right sides. 3x plus 5x becomes 8x, and the y terms disappear completely. On the right side, 12 plus 8 gives us 20. This leads to the simple equation 8x equals 20. Dividing both sides by 8 gives x equals 2.5. Next, we substitute this value back into one of the original equations. Using the first equation, 3 times 2.5 plus 2y equals 12. 3 times 2.5 is 7.5, so the equation becomes 7.5 plus 2y equals 12. Subtracting 7.5 from both sides gives 2y equals 4.5. Finally, dividing by 2 gives y equals 2.25. So the solution to the system is the ordered pair 2.5, 2.25. This point is where both lines intersect. Now let's walk through the elimination method using this example. We are given two equations, 2x plus 3y equals 7, and 4x minus y equals 5. To eliminate a variable, we first match the coefficients of y. The first equation has positive 3y, and the second equation has negative 1y. To make them opposites, we multiply the entire second equation by 3. That gives us 12x minus 3y equals 15. Now the y terms are ready to eliminate. So we add the two equations together. When we combine 2x plus 3y with 12x minus 3y, the y terms cancel completely. On the right side, we add 7 and 15 to get 22. This leaves us with the simpler equation, 14x equals 22. Dividing both sides by 14 gives x equals 11/7. Next, we substitute this value back into the first equation. We plug 11/7 into 2x plus 3y equals 7. 2 times 11/7 is 22/7. So the equation becomes 22/7 plus 3y equals 7. To isolate y, we subtract 22/7 from 7, and since 7 is 49/7, 49/7 minus 22/7 gives 27/7. That means 3y equals 27/7. Dividing by 3 gives the final value, y equals 9/7. So the solution to this system is the point 11/7, 9/7. Now let's try a beginner substitution problem. Follow the steps shown on the screen, and try to solve it within 60 seconds. Pause the video if you need more time. Let's go through the solution together. We start with equation 1, which tells us that y equals 2x plus 1. Substitute this expression for y into equation 2. That gives us x plus open parenthesis 2x plus 1 close parenthesis equals 10. Combine like terms. 3x plus 1 equals 10. Next, subtract 1 from both sides. Now we have 3x equals 9. Divide both sides by 3, and we get x equals 3. Now substitute x equals 3 back into equation 1. Y equals 2 times 3 plus 1. That equals 7. So the solution to the system is the ordered pair 3, 7. Here's an intermediate system of equations. Use substitution or elimination, whichever feels easier. Take 60 seconds and see if you can solve both variables. Pause the video if you need more time. Let's walk through this intermediate system of equations slowly and carefully, step by step. We are given two equations. Equation 1 is 2x plus 3y equals 21. Equation 2 is 4x minus y equals 7. Our goal is to solve this system using elimination. Among the two variables, eliminating y is the most efficient because the coefficients, positive 3y and negative y, already have opposite signs. We simply need to adjust one equation so that the coefficients match in size. To do this, we multiply equation 2 by 3. Let's go through that multiplication carefully. 4x times 3 becomes 12x. Negative y times 3 becomes negative 3y, and 7 times 3 becomes 21. So the transformed second equation becomes 12x minus 3y equals 21. Now we place this new equation directly under equation 1 so we can add the two equations together. Take a moment to visualize the alignment. 2x plus 3y equals 21 and underneath it, 12x minus 3y equals 21. When we add the equations term by term, the 3y and the negative 3y cancel out completely. This is the key benefit of the elimination method. With the y's gone, we focus on the x terms. 2x plus 12x becomes 14x, and on the right side, 21 plus 21 becomes 42. So now we have a clean single variable equation, 14x equals 42. Next, we solve for x. Divide both sides by 14, and we get x equals 3. This is our first variable. Now we substitute x equals 3 back into one of the original equations. We will use equation 2 because it has fewer terms and is easier to compute. 4x minus y equals 7 becomes 4 times 3 minus y equals 7. 4 times 3 is 12. So now we have 12 minus y equals 7. To isolate y, subtract 12 from both sides. That gives negative y equals negative 5. Finally, multiply both sides by negative 1, and we obtain y equals 5. So the solution to the system is the ordered pair, 3, 5. This means x is 3 and y is 5. Take a moment to check that both values satisfy the original equations. And once you're ready, we'll move on to the advanced practice problem. Here's an advanced word problem system of equations. Form two equations using the total number of tickets and the total revenue. Then solve for the number of adult tickets and student tickets. Take 120 seconds, and pause the video if you need more time. Now let's walk through the solution to this word problem step by step. This theater sells two kinds of tickets, adult tickets and student tickets. On this particular day, 62 tickets were sold in total, and the total revenue was $780. Adult tickets cost $14 each, and student tickets cost $10 each. We let A represent the number of adult tickets, and S represent the number of student tickets. So we can translate the information into two equations. The first equation comes from the total number of tickets, A plus S equals 62. The second equation comes from the total revenue, 14 A plus 10S equals 780. Now we solve this system using elimination. Step 1. Eliminate one variable. To match the coefficient of S, multiply the first equation by 10. 10 A plus 10S equals 620. Now subtract this equation from the revenue equation, 14 A plus 10S minus 10 A plus 10S gives 4 A equals 160. Divide both sides by 4, and we get A equals 40. So 40 adult tickets were sold. Next, substitute A equals 40 back into the first equation. 40 plus S equals 62, so S equals 22. That means 22 student tickets were sold. Therefore, the solution to this system is adult tickets, 40, student tickets, 22. Great job working through today's lesson. In this session, you learned how to solve systems of equations using substitution, elimination, and even a real SAT-style word problem. These skills are essential for both Section 3 and Section 4 of the SAT math test, and mastering them now will make the actual exam feel much more manageable. As you continue practicing, focus on choosing the most efficient method for each problem and take your time to avoid simple mistakes. The more familiar you become with these steps, the faster and more confident you'll be on test day. Keep reviewing the examples from this video and try a few similar problems on your own. Consistent practice makes the biggest difference. Thank you for learning with me today. You're making great progress, and your improvement is real. Keep going, and I'll see you in the next lesson.